My name is Igal, and I own product-wise runtime for the VMs in Azure, and with me is Ziv. And Ziv.
Yep, I work with Igal. We are the Azure Compute team, responsible for availability and your sleeping patterns.
Thank you. As you can see, we deeply care about sleeping patterns. High-level agenda, we'll talk about availability from all the different perspectives. We start from availability of a single VM, what can be done to get it better, what kind of scenarios we need to consider. And we'll, of course, as we go, we'll introduce new services, new capabilities. And we will eventually talk about how to improve the availability perceived by your customers. So we'll just go topic by topic. You'll see a lot of announcements embedded in the presentation, but we are kind of doing it in a way that we are slowly building the service from small service into a larger service while showing what we have new, what kind of new features we have, and what existing features we have in order to create the service in a highly available fashion. So let me start first with why is it important to have availability? And this is just a picture of the ship, but this is actually the ship that was stuck in one of the ports, and it happened due to the fact that the service was responsible for getting the shipping papers for the ship was not up at that point of time. So the time lost was inability to move such large ships, such large containers from the port. And it's not just one ship, by the way. When this happened, many ships, many different transport vehicles were stuck because they couldn't go to their next destination. So in the world today, it's really not an option, not a question of having or not having the high availability. Different services, different dependencies, definitely there are some critical services like this, but you have to take availability into account. You have to consider what are your end customer expectations when setting up the environment. And I reference this book. It's about normal accidents. Essentially, how do you prepare for accidents in advance? How do you consider the failures before they occur? How do you set up your entire environment, your entire service in such a way that failures is just an expected thing that happens, I don't know, maybe not every day, but expected to happen. So kind of normal living with accidents. So how we are going to analyze this? I think the basic assumption is that we don't want to see outages for your service, and we want to make sure that services are resilient to any kind of planned activities, planned maintenance. So even if you need to do some maintenance, you take it into account when setting up the service, and not, of course, not when you need to do the maintenance. We have this kind of concept of pyramid where we have some I'll just go over it. And it's like when you have physical assets, physical machines, it starts from their availability. And they can be awesome, they can be super expensive, provide really best-in-class MTBF, but in many cases, we can do better than what they can do just because we have so many software tools, so many prediction analysis tools, machine learning, and such a large environment where we can train our systems to be much better than what just hardware can offer us. Above that, above the platform, there is your service that needs to use certain functionality, needs to prepare for availability events, and need to be built in such a way that its availability is better than a single Azure platform component. So essentially the idea is that every tier, every layer is responsible for its own availability, and every layer, every tier adds more to availability and adds, I don't want to say another 9, but adds another layer in your availability cake. It's like in security. It has to be tiered approach in order to achieve the best possible result for the end customer. So I'll start first from the last slide. This is the last slide, but I'll start first from the last slide. This is what we are going to talk about. We're going to slowly build it, but we'll start from some basic apps that run as a single VM, which is a legacy, we call it legacy app, single instance VM, just one VM. Not a highly available configuration, but nevertheless, some applications can just run on one VM. It is what it is. So we're going to talk about what you can do in order to provide the best possible experience for that single VM. We're going to talk about the highly available apps, which have multiple instances and prepare for single instance failure. Eventually, we'll talk about regional resiliency. We have some new exciting announcements in this Ignite, and we are going to dive into those announcements shortly. And of course, eventually, you want to make sure that your service, for some service at least, it's global scale. It has both local and global presence, and in some cases, there are data residency issues, so you need to take this into account when you're designing your service and when you're designing higher availability for your service. So that's basically what we will achieve. By the end of this presentation, we'll talk about what kind of functionality you need to build for each type of the application, and hopefully, this is also a journey of growing your application. You might start with some simple proof of concept as a single instance, but eventually you might grow into highly available application running across zones, across regions, and being so successful that you need to think about its performance and the capacity and so on. So, simple single instance VM. We are the only cloud actually that offers 3 nines guarantee for single instance VMs, which are running on which are backed by premium storage. So if you are using premium storage, we are doing essentially a lot of work in the background, and I'll talk about it in a moment what we are doing. But we are doing a lot of work to ensure that even your single instance VM running on a single piece of hardware can get certain level of SLA. I just want to make sure we are on the same page. It's not high availability. It's best attempt to give as much availability as possible to a single VM. And to be completely honest, I just sharing here our numbers, average VM availability that we measured, and across production, this is our internal numbers. We have Gartner continuously measures us as well. But I think what it shows is that we got essentially to average experience of 5 nines for a single VM. But once again, this is not enough, not high availability, not taking into account the planned maintenance. It's a starting point for your journey, and I just acknowledge that some customers need even single VM to be highly available, and we of course want to make sure that every VM is as highly available as we can. And of course, the idea is that in order for you to move any app into the cloud that exists in your data center and might be still single instance, you might want best possible single instance support from your cloud provider. And this is what we are trying to do here. And we are doing that with a set of interesting techniques, interesting tools, and I'll just talk about one of them. We call it predictive availability. So we are trying to get ahead of the failures. Consider the size of our environment. We can gather all the telemetry across the environment. We can gather the information about the failures that actually occur and try to predict those failures before they have manifested. So essentially the idea is try to predict hardware failure before the hardware failure has impacted your VM. In some cases, we will be able to live migrate your VM from unhealthy node in the future. In some cases, our predictions might be wrong, and we will not be able to migrate you. It might happen, the failure might happen either too soon based on the prediction, or the failure might have already happened and you suffer your VM suffered the downtime. Anyway, in both of the cases, we will move you to a healthy VM, and in both cases, we will perform automated RCA and analyze how this kind of similar kind of failure can be predicted. We are focused on detecting grave failures, and we recently published a paper about it in collaboration with MSR. It got picked up by the press, to our surprise. Apparently, it's a big issue. The availability is a big issue, apparently. We are starting to focus on grave failures. Essentially, when your code is performant, but not getting everything it expects to get from the underlying platform. For example, could be some performance degradation, or degradation just in some of the passes of the application. So we are starting to focus on what can we do in order to detect those grave failures and take preventive actions, or in some cases proactive actions to a full failure based on those grave failures. And if you are really interested in this, I put a link here. You can download the presentation, look at the link. But we have a bunch of patents and a bunch of publications just on this topic, super focused on making sure that single instance VM can get the best possible experience. So a couple of more points, minor points. Any new code going to production in Azure we will ensure that it doesn't impact the baseline behavior of the applications. Once again, bunch of machine learning logic that allows us to establish baseline behavior of the application and ensures that applications do not change behaviors after platform changes are deployed. And the last point I want to mention, and we'll show some more in demo slides, resource health check got revamped. It's pretty much similar function, but we completely changed the engine underneath. It's much faster. Within a minute, you are getting the status of your VM, and either you shut down your VM and it shows that you have shut down your VM, or platform misbehaved and you can see why. We are quickly showing it in the resource health check, which is essentially the VM health properties in the portal and in CLI. And that's it for the topic.
Yes, so taking this to the next step, first aspect of availability is reporting and actually providing you with visibility to the high-level status of Azure and your assets in Azure and the ability to drill down, as well as a bottom-up approach where you're looking at a single VM and see, hey, which issues occurred which impacted my VM? Could be specific to this VM, or could be in broader context which impacted your VM. So with that, we'll dive to kind of a live snippet of how are we doing now. And our journey starts with the Azure Monitor. And here, basically, I just opened the Azure Monitor and realized that there is one service issue. Currently, this is live. So currently one active service issue somewhere in Azure impacting my VMs. And I also have, in the last 6 hours, 9 activity logs errors. So let's see actually what's going on with Azure, because this is really interesting. I didn't know about that. And this is not planned by any means. So currently, there is a storage-related incident impacting North Europe. Well, I hope that won't impact our session. But you can see that it started 3 hours ago. And also, you can see if the team bothered to update. No, they did not. So here, basically, I can learn about updates for this incident. But the cool stuff is like, hey, I'm not looking at the monitor to see what's wrong with Azure. I want Azure to tell me. So in a way, I moved to the alerting part of Azure, where I can predefine alerts to notify me, let me know with issues related to availability and maintenance and other aspects. And one of the cool features in Azure Monitor is the ability to define alerts with multiple channels. And by multiple channel, this is, for example, one of my pre-configured alerts. We'll talk about maintenance later on today. So you can see this is a maintenance approaching alert I have configured in my planned maintenance validation subscription. And the action is something called maintenance alert. And this maintenance alert action has multiple channels. You can see it will send emails to myself and my best buddy, Harsh. And it will send me text messages to me and Harsh and this lovely Duty Gal. These are not really our phone numbers, but you get the point. So that was the next step, to configure monitoring alerts and let yourself know of any issue impacting either individual asset or a broad set of assets. Then, when looking at an individual asset, let me just go pick my favorite dev machine. I can also look and see hold on, where was I can also look and see if there were issues impacting my VM, I can look it from that specific VM. Now, my VM is currently running, with a critical, oh, that's a backup, sorry. Where's my service? Yeah, I can see all sorts of recent activities impacted my VM. And also, if I decide to open a ticket to Microsoft, something wrong with my VM, as I walk through this wizard, try to open a ticket, Azure will try to help me with that in order to surface any known issues, such as this outage in North Europe. Now I see folks checking there. I hope your Azure mobile app to see that whether your deployments are being impacted. But basically, as I move through this, Azure will surface any existing issues. Let's see, if I pick Azure Virtual VMs, I picked backup, sorry.
So essentially what we have added here is what we call automated RCA, automated root cause analysis. When you're attempting to open a ticket, even before your ticket went to support, we'll try to analyze all the patterns, everything that happens with the service underneath, and show you the best possible root cause that we think is relevant for you. If it's some kind of an outage, we'll show more outage details. If it's some kind of behavior, I don't know, you shut down the VM, we'll tell you shut down the VM, so that's why it's not working. In some cases, we will give more details like you cannot connect to your VM because you have misconfigured your IP addresses, IP access. But we'll essentially attempt to support you even before you open the ticket or even before you specified what's wrong. Because basically we know what's wrong, we just need to find what is a probable case for opening a support case.
Yeah. So actually what I wanted to demo is the history on for a specific VM. So that's when I try and open the ticket or look at the resource health, I can look at what happened to which impacted my VM. So
yeah, and in this example, we see that it was down because customer decided to shut it down.
Yeah. So next step, we talked about the fact that a single instance VM is not really highly available. You want to apply both backup and disaster recovery plans to your VM. So let's start with backup. Azure provides you with a way to configure a scheduled backup, either daily or weekly, with a predefined retention policy. You may say, I want to keep 5 days of backups and 5 weeks of weekly backups. And also an option to initiate a backup interactively from the portal or API. So what I'll do, I have created a very simplistic LAMP stack VM, single instance VM with an Apache and PHP and MySQL. And I installed an application, WordPress. So and that's my WordPress blog. Okay, it's kind of fun in Ignite, and I just put few posts here. And the point here is that the point is I can pre-configure the backup, and then when I want to, I can decide to restore. Now, when I decide to restore, basically I have two options. Either to replace the VM, replace the disks, basically, and bring it back to the same state, or create a new VM from that restore point. This is best when you want to check something. You don't want to interrupt the current production environment, but you want to see, hey, what we had there 2 hours ago, 2 weeks ago. You know, this is one of those classic cases with someone, hey, I just deleted the database. Can you just figure out and bring just this database? So you want to set up a new VM with the older data. So what I've done here is just an hour ago, I triggered restored. Okay, I wanted to restore this VM from yesterday's build, and I have asked for this to be a new VM. So you see that it took Azure Backup a few minutes to transfer data from the vault, and then restore the VM, created another VM, a new VM. And if this is my current VM, I'll just go and add another post. Having fun in my session. Good enough. And if I go back to my dashboard, I need to pick up this VM. So the restore point I did just an hour ago, I asked it to create another VM. And the VM is actually a virtual machine. You can see that I have my LAMP VM, and I have now a restored LAMP VM, which is basically the same VM with the state based on the backup I took last night. So all I want to do here is basically just to copy this IP and go and show you that this WordPress has less comments. So that's kind of I basically restored everything. The VM, the Apache, the PHP stack, MySQL, and WordPress. So basically this enabled me just to show you what happened before. That was backup and restore. And again, backup could be either scheduled or on demand. Let's move forward. All right, disaster recovery. So with disaster recovery, let's go back and just discuss this over the demo. It will be faster. So the idea in disaster recovery, we enable you to put up disaster recovery policy to another region. We keep talking about availability of a single instance VM. Soon we'll talk about availability of multiple VMs in the same region. But you need to also keep in mind that you do want to have some sort of a disaster recovery plan. Now, your disaster recovery plan may be just copy the storage, maybe replicate the database, or maybe to replicate a specific set of VMs, like, I don't know, domain controllers if you use your own. So with the Azure disaster recovery option, basically I'm going back to my LAMP VM. And I scroll down to the disaster recovery preview, and I can see that basically I have asked for the settings for the disaster recovery, indicating the destination region and the name of the recovery vault and all sorts of additional settings. I can apply it on a single VM, on a resource group, and I can automate it with scripts or Azure automation to have any new VMs in a specific resource group to be added to this disaster recovery policy. Let's move on. Going back to the specific VM. So there are cases where stateful workloads, actually running multiple VMs, are impacted by any downtime to a specific VM. It could be if we run maintenance and we take those VMs one after the other, and you need more time between those reboots. Or it could be that you have, you can save state, okay, quiesce the VM, say graceful shutdown, or initiate a proactive failover. Let's say you do have a disaster recovery or you have a standby server. You may want to proactively direct traffic to that server or set up a script, any workload specific or IT specific workload. For that, we have surfaced Azure scheduled events, which is basically a way for you to query for those events before they happen from within the VM. Let me rephrase. We offer a local non-routable IP with a very simple REST endpoint that you can query. It's part of the VM metadata service. So you can query and get for events before they happen.
Let me rephrase that as well. We offer a crystal ball to tell you what will happen in some minutes, whether the VM is going to go down, and if it is, what we know about it, why. So in cases where we have underlying hardware failures that we can predict, and the only mitigation is essentially to shut down the VM and start it on another set of hardware, we will first surface the event. Once again, if it's possible, we will surface the event and tell that your hardware is about to fail, we are moving you. So we will try to do any changes, either planned maintenance or unplanned downtime in such a way that it's gracefully communicated using scheduled events. You can, of course, follow up on these events in any ways that Ziv just mentioned, but you can also just log the event so that you have some kind of information about why my VM just went down.
Yeah. Now, the purpose of surfacing those events were actually to automate some sort of failover logic. It could be an application specific or your IT specific. Let's say you want to open a ticket or you want to span a new VM or increase the size of something else. So for that, again, I mentioned the event is surfaced from within the VM. So one of the requests was, hey, can I consume all of those events from all of my VMs in one certain place, one single place? So for that, I'm going to show you a demo in which I'm going to surface those scheduled events using Azure Event Hub. And from there on, you can consume those messages from Azure Automation or any platform of choice. So the code I'm looking to share with you is actually on GitHub. And it's a very simplistic Python sample. What it does, it builds a token, that's Event Hub token, but basically it performs a simple get call, URL get call, to this metadata scheduled event. And basically then, this is like an interactive sample, but you get the point. It will, if it picks an event, it will send it as a message, so you can consume it outside the VM. And it will ask you, hey, do you want to wait or shall I continue? And as part of this contract, we surface a property we call not before. So this not before basically gives you the heads up time. Usually it is 15 minutes. It could be 10 seconds, usually it's 15 minutes. It could be 10 minutes in few use cases. But in those 15 minutes, you can pick up the event. You can perform any application-specific logic, like initiate failover. You can send this notification to an admin or some sort of ticketing, or even just store it locally. So later, if you're trying to do root cause analysis, you know that this reboot was actually triggered by Azure. Now, after you're done with all of this logic, basically your VM is sitting idle. So what you can do is you can call post with the same URL and basically telling Azure, I'm done, you can proceed. So this is exactly what this sample does. It picks the event. Again, this is an interactive. And it will ask me, do you want to acknowledge? And if I do, it will do the post, and then Azure will take down the VM. So I will demo this in my dev machine. Come on. So you can see that I called this interactive tool. No events were returned, and I send to Event Hub that I'm okay. It's just a debug mode. Now, how do you test an application-specific logic for those sorts of scenarios? Basically, all of them are scenarios that we initiate. So for that, we basically enable you to get those notifications even if you reboot or redeploy the VM from the portal or CLI. So for that, where was my box?
So while Ziv is showing, essentially this means if someone tries to shut down the VM from the portal, we'll still protect from this accidental shutdown. If it was working VM, we will do a graceful shutdown for that VM, essentially allow you to take action before the VM forcefully goes down. So this means the response time from the portal, if you are using this feature, will go up. It won't shut down immediately. It will only shut down when the VM acknowledges to do so.
All right. So I go and ask for restart. Now this request go to our control plane, goes all the way down to the specific control plane of that VM, and it will surface from within the VM within a few seconds. Let's see. I call the same utility, and whoops, what happened? The VM detected, is that a pointer? Yeah. It's impossible. Okay, so what happened? The VM detected a new event ID. The one starts with a, I scroll over down a few keys. Yeah. So it detected an event type of reboot, status being scheduled, and on that resource. Now, the VM is still running. By the way, it keeps asking me, do you want to acknowledge the event and move forward? So at this time, I don't want to acknowledge. Let's do a no. Just to show you that the VM is still running, right? I can play along with it and so on. And the event is waiting. So Azure wait, give me these 15 seconds before taking down the event, and I can do whatever I want. Okay, let's say I keep using the VM. I'm done. I saved my state. I made sure that I have my backup. I took the IP out of my load balancer pool, or whatever you want. And now basically I can move forward. So next time I call this utility, I will say yes, acknowledge the event. Okay, again, it's the same event. The event is still waiting. And you can see the time it waits. It's kind of hard to read. It will wait until 5:15. So I have 13 more minutes before the Azure will take down this VM. So let's say the VM is idle. I'm done. I hit yes. And by the way, all the time, they keep sending those messages to Event Hub so that my admin can respond. So I didn't count 5, 6, 7, 8, 9, 10. The VM will, this SSH will disconnect really, really soon. Yep, done. Okay. So Azure now took down my VM after I completed my graceful shutdown, and we'll proceed with the reboot in this case. All right. Earlier this week, we have announced a new experience regarding planned maintenance. Now, planned maintenance is where we need to basically roll out changes in a way that we have to impact your VMs. The vast majority of planned maintenance don't really impact your VMs. We do patching using a technology which we call VM preserving maintenance. And with this technology, basically, we freeze the VM for a few seconds, in average between 2 and 5, or in other words, up to 30 seconds. We change all the underlying agents, components, DLLs, security patches, and so on, and then resume the VM. Memory is preserved. 30 seconds is the TCP default timeout, so no open connections are impacted. However, by the way, if you have a workload where 5 or 30 seconds freeze is actually impactful, imagine a remote desktop service, or a gaming platform, or a trading application, right? Those freeze events are actually surfaced using scheduled events. So you can react. As part of the event that I showed earlier, there was type. The type in this case will be freeze. So you can write logic to compensate even the freeze time of the platform. Okay, in other words, if we needed to freeze your VM for a few seconds, you may react before we do that and get better availability. All right, so that was the VM preserving maintenance. However, there are pretty rare cases where we need to impact your VM by rebooting the VM. Imagine one of those cases where we actually need to move you to a newer hardware decommissioning. Another scenario is, for example, where we're going to replace the underlying hosting environment. We're looking to roll out the latest from the Windows team. So we need to upgrade the entire hosting environment to enable many new features that, frankly speaking, were developed for Azure. We brought many new scenarios and requirements to the Windows team, and we want to enable them. Better performance, better availability, better pricing models as well. So for those cases where we need to reboot the VM, we heard the feedback that customers are actually asking for 3 things: better visibility, more control, and reduced impact. Let's start with the reduced impact because that's the easiest. You guys don't want us to reboot your VMs. Makes sense, we understand. This is why we clubbed together all the impacting changes and defined an internal budget of a single annual VM reboot for our maintenance. While I keep saying this, define this budget, we keep investing in technologies such as live migration to even this single annual reboot to take it off the grid. So that's reduced impact. Let's put this aside.
Yeah, by the way, last time we did it was a year and a half ago. So we are trying very actively for anything coming, to deploy it in such a way that it's coming as a preserving maintenance. But in some rare extreme cases, it might not be possible.
Yeah. So how will it look like? We will start a maintenance wave by notifying you several weeks ahead of time. And we will start what we call a preemptive window. And this notification will be surfaced as in Azure Monitor, so you can define activity log alerts and get text messages when we announce this maintenance, or actually put your DevOps team on the mail as well so that they can react. Usually we heard that many customers being a subscription admins, basically those are the guys with the credit cards, but they don't do the daily operations. It is either the DevOps, the dev teams, or it's basically maybe they have a vendor like a shadow IT. So you can now add those guys to the notification channel by configure and set those activity log alerts and add more recipients to the email notification. Also, as I mentioned, you can use now text messages and webhooks to automate the response. Now, after this notification time, we are still in this preemptive window, the green time frame. You can now discover the maintenance status for each of your VMs. One of the common questions was, or the common ask was, tell me when this VM has gone through the maintenance. I want to know when you guys are done. So now we surface this information as part of the VM state. And third was, hey, give me the option to schedule the maintenance on those VMs. You give me this month, I understand. I want to set maintenance to happen Tuesday night. I want to set maintenance to happen across all of my tiers in my application. I can take down the entire application. Or I need to negotiate a time with my end customer. And I need 2 weeks time to negotiate this window, but then I get 4 hours window. So for those use cases, we surface this option to initiate, start the maintenance within this time window. If you choose not to, then we move to the second window, which is the scheduled maintenance. And somewhere in this window, we will take down the VM. Oh, by the way, before we do that, we will give you the 15 minutes scheduled events. So you can still write logic to become resilient to those VM reboots by leverage scheduled events. And it will work if you initiate it from the portal, the demo I showed you. It will work when we do the freeze, and you'll get an event time of freeze, so even for a few seconds. And it will work for the VM rebooting maintenance, the impactful events, where you can react, save state, initiate proactive failover, and so on.
Of course, if your service has multiple fault domains, if you have defined scale set or availability set, this operation will still, the automated part will still honor those fault domains, update domains, and we will not take your service layer down entirely. So we'll still ensure that when those automated VMs are happening, they're happening update domain by update domain rather than at the same time. So in cases of highly available applications, or in cases of applications using scheduled events, you really don't need to do it manually. The idea is that there is enough automation that can be done on the platform, using the platform functionality to avoid manual scheduling of the VMs, of the VM maintenance.
So I got the email, and the email has basically nothing in it beside the link. And the link will take me to this dashboard, where I can learn about what planned maintenance cycles or waves happening at this time. I can look and read more updates. And by the way, we now have a planned maintenance cycle which will end to Sunday, and in one region, where we gave customers the opportunity to play around with this experience. So if you are quick, you can either now using your mobile app or later create a VM in US West Central, and it will probably be set automatically for maintenance, and we will just want to play around with this experience. So,
and the current maintenance round is in preview, so your feedback is of course welcome.
So beside that, I can look at the impacted resources and see for this subscription, these are the VMs which will be impacted, and I can also see that 2 were actually completed. So as you can imagine, I already had 2 sessions this week, so I tried each VM in each session, and here we're going to try another one. So I'm, oh, this is actually my LAMP VM. This is the single instance WordPress server, so I'm going to pick it. And I see the detailed timeline, so I know exactly that I have until October 2nd, and then Azure will take it down. And basically, if I'm happy, if I'm good, I hit start maintenance, and Azure will take this VM down. Oh, by the way, it will wait another 15 minutes because I have the logic inside the VM. So if I try the same demo I showed earlier about scheduled events, it will show a new event. So in other words, planned maintenance. Better visibility, better control, reduced impact, combining planned maintenance experience in the portal and CLI and PowerShell and API with scheduled events from the VM, you can have more control and you can become more resilient.
Thank you, Ziv. So we talked about single VM, and let me just quickly recap what we have. We talked about planned maintenance experience. We talked about the fact that you can have single instance SLA if you are using premium storage. We talked about scheduled events and how you can automate the availability scenarios with scheduled events, essentially the crystal ball. And we have shared some of the scenarios for VM backup and disaster recovery. Once again, this is interesting. This is not enough. In order to achieve higher SLA, in order to achieve higher availability, you need to prepare for failure of the VM in such a way that there is always another VM running ready to pick up the load, at least one. In many cases, you will want to distribute your workload across large amount of VMs, so there is no visible customer impact even if one of your VMs goes down. So our next step would be to see how we can define and manage availability sets or scale sets on Azure that will provide you such a capability.
So the concept behind this high availability across multiple resources is fault isolation. You want to be able to create 2 virtual machines or 2 disks or 2 storage accounts on different and make those isolated in a way that if one fails, the other will remain active. And the basic construct for that is availability sets. So we had availability sets since like ever. And the idea is that within availability set, we surface fault domains and update domains. So when creating multiple VMs, you put them in an availability set, any number between 2 and 100. And you get the isolation in terms of fault domains, which today are mapped to physical racks. In other words, if I create 3 VMs within an availability set and I ask them to be on 3 fault domains, Azure will put them on 3 different racks. If I create 30 VMs and ask for 3 fault domains, I know that I get at least 3 racks. It could be more. And the idea is that we surface this information, the fault domain ID, per each VM. So if I have a stateful application or any quorum-based application, and I need to allocate replicas, instances of a replica, I basically need to pick resources from 3 different fault domains. Okay? Most modern data platforms already use fault domains. If you write your application, you should use it as well. If you're using something from the template from the marketplace, most likely that they use it already. And you need to have, like, we started with the 3 nines SLA. You need to move to something like availability set or scale set, which I will cover soon, in order to get to the next level of SLA, which is 3.5 nines. Now, 3.5 nines talks about the availability of the overall set. In other words, the last man standing. So what is the probability, or what's the SLA Microsoft guarantees to have at least one VM? And by the way, if you think of at least one VM, the very common topology is SQL always on when we're looking about 2 servers and a witness. So last man standing is good enough for that one. Now, one of the updates we announced earlier this year was managed disks. So managed disks provide many, many values, starting with simplicity and scale and additional few more cool features such as snapshotting and so on. In the context of availability, it is important to call out that an availability set with managed disks is something we called managed availability set. Now, as I mentioned, it's all about fault isolation. So with availability set, you get fault isolation for the compute layer. If you use an availability set with managed disks, you get fault isolation for the compute as well as the storage. In other words, if you use 3 fault domains within your availability set, you actually now get 3 storage fault domains. In other words, if one of the storage clusters, storage stamps, fail due to usually it's a software issue or man-made disaster, then it will just impact one of your fault domains, one fault domain in your application. So by taking availability set and managed disks, now you get the fault isolation both for compute and for storage. Once you have availability set, one of the common topologies is to put a load balancer on top of it, which will work as, like, you'll have a single IP to serve multiple VMs within the availability set. That's kind of one of the common topologies we see with customers, which brings us basically to the next level of availability.
Yep. So there's echo when I'm not on stage, apparently. So the next level is what we just discussed, is highly available applications. The assumption is that you are using some kind of load balancing in order to implement load balancing across multiple VMs. Customers are accessing load balancer behind which you have the VMs that implement the functionality, or maybe multi-tiered applications that implement the functionality. You definitely need to use managed disks. Every disk that we offer, managed or unmanaged, is implemented using 3 copies inside our storage. So it's not the protection against a single disk failure. We are talking about protection where multiple replicas of the same disk go down, and as Ziv said, in many cases it's actually a software issue or maybe some kind of a networking partitioning issue. We need to be prepared for every type of disaster. So despite the fact we are prepared against a hardware disaster with any disk, with managed disks, we are also prepared against types of disasters where we have entire storage stamp becoming unavailable. Definitely, you can still use scheduled events and you can still use disaster recovery. Scheduled events are getting much more interesting scenarios here. The failover, as Ziv mentioned earlier, becomes much more interesting. Many of our customers started using scheduled events in their applications in such a way that they change the timeouts. So essentially, when there is a freeze coming, they change the timeout so that application will wait until the freeze completes and only then perform failover, if failover is costly. In other cases, some customers might want to do failover before the freeze so that freeze doesn't impact the application. And we talked about some of the trading applications or gaming applications which might be relevant. But bottom line is, a lot of data is available in advance. A lot of knowledge is available in advance. As we are advancing our platform, we are becoming smarter about even hardware events that we don't get as events, but we can kind of predict them based on certain parameters of behavior, certain parameters of the baseline, and we can surface to use those events as a value to your application and mitigate any potential availability issue before it happens.
All right, so now let's go down to the physical aspects of Azure and talk about data centers and physical assets. So I mentioned that racks basically are the base fault isolation in Azure, and we map those to fault domains. The main reason we do that is that all the components of the physical systems above rack have redundancy. In other words, a rack is a single item where if I take out, your VM is impacted. In the rack also there is a single power distribution unit, PDU, where if it goes down, the entire rack goes down. All systems above the rack, power, cooling, network, I don't know. We learn a sewer system, right? We learn of those as well. All of those have some level of redundancy, and we are not using them today in the software stack. Now, if I look top down, Azure Surface around, well, not around, 40 regions today. It's hard to keep track. If you missed recent announcement, we have announced 2 new regions in France, 2 new regions in Korea, 2 DoD regions in US, and 2 new regions for Australia government, and 2 new regions in South Africa.
It's becoming harder and harder to find a place on a map where we don't have Azure region.
Yep. Now, when the principle is very simple. When we go to a country, a new country, we want to go with 2 regions. And there are 2 reasons for that. For you, as an application designer, we want to give you an option to do disaster recovery to another region while maintaining data sovereignty. More and more businesses today are subject to all sorts of compliance, regulations and rules and demands for data sovereignty. So by doing disaster recovery schema in Korea, is there anyone here using from Korea? Whatever, so I picked Korea. So you can perform disaster recovery from Seoul to Busan, our 2 regions in Korea, while maintaining data will never leave the boundary, the physical boundary of the country. That's data residency. Now, earlier this week, we added another layer for this discussion and finally introduced availability zones. Now, availability zones, one of the features which has always been a gap between us and our competition. And the idea, we keep talking about fault isolation. The idea behind availability zone is to provide fault isolation for those physical systems within the data center, which are redundant, but subject to all sorts of man-made disaster or Mother Nature. And in general, availability zones are physically separated. So those are 2 separated data centers, okay? At least 2 buildings. And when we go to a region, actually I made a mistake. We start with 3. So each region today supported with availability zones has 3 zones for you. Now, we do this zone mapping, so your 3 zones are different than your 3 zones. But the point is, like, each customer will get 3 zones in a region. And for us, it was a very long project because we had to fit existing data centers and network topologies and decide on when and how to grow in those regions where we do want to support zones. For you, basically, it gives the simplicity of being able to assign a VM to a specific zone, create a standby VM in another zone, or create multiple VMs in 3 different zones and add a load balancer to spread and span those zones. This is, by the way, if you are considering SQL always-on IaaS topology, this now becomes easier. Or if you want to scale, you can create scale sets or scale sets in 3 different zones and pin each scale set to a zone. Currently, we are in a public preview, and there are 2 regions open for this public preview. West Europe and East US too, and limited size of VMs. You can try it out today. This preview is open to all. The way to look at zones, basically from an ARM template, from a resource definition perspective, being a compute resource, you can specify a zone, or a managed disks, you can specify a zone. And by the way, if you don't, we will try to co-locate your managed disk in the same zone as your VM. Otherwise, it's kind of awkward and not really highly available. And also for an IP, you can create a virtual IP and pin it to a zone.
So we had multiple sessions on manageability, and
I guess we had.
We had. By the way, all are available offline for you, so you can still look at them. And we discussed in more details how templates look like and what exactly can you configure there. But I think the important point here is that you really don't need to change the templates. You just add the zone parameter. So it's all backward compatible, essentially, with your existing management capabilities. All the investments you already did for managing your services on Azure, you just take them ahead, add another line, specify zone, where you want your resource to be, and it will work. Yep. So for us, very explicit point was make sure that we take our customers with us to this journey and don't create a tough migration scenario.
Earlier I mentioned the VM scale set. And in a way, VM scale set is the next generation replacing availability set. The idea is a single construct in Azure which manage many, many VMs. So if you have identical VMs and you want elasticity, you want faster deployment time, you basically take VM scale set and just specify the number of instances. In the context of availability, VM scale set provides the same fault domains as an availability set, but when we introduced zones, we also wanted to give you an option to do a single scale set which basically spans multiple zones. This feature is currently available as part of an early access preview. So this is not a public preview. If you want to try it out, reach out to us or anyone from the Azure Compute team. We will be happy to bring you on board this preview. But the idea is simple. You basically have a single construct which can hold to up to 1,000 VMs. So you have elasticity. You can configure autoscale based on CPU, memory, or other indicators to scale, grow, and shrink your scale set. Again, it's a single resource in the ARM template, in the Azure monitoring, and you basically get a simplified management experience. Also, the fact that this scale set spans multiple zones, you actually get better availability or better resiliency, because now if the entire building goes down, VMSS or VM scale set will try to compensate if you turn on autoscale and provision more instances in the remaining 2 zones. So if you started with, let's say, 300 VMs across 3 zones, you have 100 each. By the way, VM scale set will balance or level the number of instances in each of the zones. If one of the zones came down, you are now 100 VMs short. So VMSS with the autoscale will try to compensate and add more VMs to the remaining 2 zones.
So I think it's worth mentioning why this concept is adding rather than replacing. And in the past, we have multiple fault domains. So we have still multiple fault domains within each scale set and within each availability set. We are not dropping fault domains. Those are still remaining. We are adding on top of that another layer of high availability. And this essentially means that your availability on Azure is going to be higher just because we have those two types of availability, both fault domains, where we have independent VMs, which are not impacted by the same hardware outages, by the same, in many cases, software outages, and also different availability zones, which have different failure patterns, different failure modes. So essentially, you are getting best of both worlds, and this is why when we GA availability zones, we are planning to announce SLA of 4 nines, which would be the highest in the industry. Because you have those 2 layers, 2 dimensions of protection, those 2 dimensions that we mentioned before.
All right, thank you. So, how does it look like? Okay, and I doubt we have time for a live demo, but basically you take your scale set and you just indicate the zones you want to use. So in this case, I picked zones 1, 2, 3. I can decide to use just 2 zones, but basically this is the only change you make to the scale set template. And also, you need to use another feature announced this week, which is the standard, or we call it internally the load balancer v2. But basically, you take your public IP address and you specify a new SKU called standard. Go check out standard virtual IPs. You'll get the comparison what you're getting by setting your IP to this new SKU. Once you do those 2 minor minimal setting changes, you basically can get up to 1,000 VMs spreading 3 availability zones with a single IP and the load balancer across all the 1,000. We have a utility which enables you to monitor scale set. This is how it looks like, multiple VMs in each of the 3 zones. And one more announcement, actually 2 days ago, I think, or pre-announcement. We have announced the zone redundant storage. So in a way, we had some sort of a zone redundant storage offer for years. But now with the new form of availability zones, we actually retrofitted this offer to use the availability zones. So the idea is that all the read writes are resilient to a single cluster, which we had, and also a single data center. So if we lose the entire data center, we lose the entire availability zone, your storage is still available. Now, the huge benefit of zone redundant storage, ZRS in short, compared with a geo-redundant, with a geo-replication, is that because of the fact that availability zones are relatively close together, or network-wise, we are looking at less than 2 millisecond latency, you can have synchronous replication. You can run application which the data will be synchronously copied to those 3 zones. And in a way, we do it with our ZRS offering. So zone redundant storage coming later this year. And we plan to G8 first half of 2018. And with the ZRS, you basically now have the 3 or 4 options for storage redundancy, either locally, local redundant storage, meaning 3 replicas happen to be in the same logical storage cluster. ZRS, meaning multiple copies in multiple data centers, multiple availability zones synchronously. No, I need the slide back.
Sorry.
Oh, synchronously replicated within the region. Or geo-redundant, which is an asynchronous copy storage offer. And RAGRS is an asynchronous copy where you have read access right to the remote destination.
Cool. So one thing that we mentioned earlier, all those samples, they're all available offline. Every sample has, when we presented samples, we added a small link in each slide. So if you want, you can download the slides, go to the link, download the samples, play with them. Feel free to comment and give us feedback. So we talked about getting to 4 nines, essentially the best SLA in the industry, and we are aiming to do that with the functionalities that we just described. The next step is to consider region pairs. So unlike our competition, we are also setting region pairs. This is essentially for disaster recovery. We talked about Mother Nature. Mother Nature can create floods, earthquakes, and other unexpected events for which some of you at least would like to prepare, or some of the applications have to be prepared based on compliance, at least compliance requirements. We are setting the region pairs in such a way that we are never updating our software at the same time in both parts of the region pairs. This is a man-made disaster, but we are also setting them up in such a way that they cannot be impacted by at least most of the natural disasters we can think about. We are trying to keep them relatively close so that they are residing within the same data sovereignty domain, data sovereignty locale. But we are also making sure that they are not too far from each other. So they will not be subject to 2 millisecond response time. You can measure different response times between two different regions in a region pair, but they are subject to separate management, and we are making sure on our side that we are never touching them both at the same time with the same change. Many of our customers are choosing to do backups across those region pairs, so that in case of need, this backup can be invoked and used in a different region pair. So compute resources can be set up as a pair. I have a list actually of what can be done here. I won't go into the list given that we don't have much time, but it's important to note that we considered all the possible scenarios that might be needed in the disaster recovery case, and we are trying to give you the opportunity to use those zones in such a way that your application is successful with its disaster recovery implementation without violating compliance boundaries or data residency boundaries. When we are recovering regions in case of, once again, we are preparing for any scenario. In case of global disaster that we can think about, we'll also take into account region recovery in such a way that at least one of your region pairs will be recovered quickly, potentially much quicker than the other region. Of course, we'll try to do our best. We can think about so many global disasters, but we are making sure that at least one of the regions will be able to come back up as ASAP. Platform provided replication features are also working across region pairs, and when you're selecting region pairs in the portal, you will see that we kind of link together those applications in your regions. Bunch of services, I started to mention it, bunch of services are aware of the multi-region environment. One of the examples is Cosmos, our internal implementations of blob storage. When you select a region pair with blob storage, it will be replicated across the regions. Anything else?
Yeah, we kind of realized that managing resources or managing disaster recovery is kind of complicated and complex. So we want to offer more and more, as you can see, mainly around data tier services. All the managed services now have multi-region option, being either SQL, but also the managed MySQL and managed Postgres. The storage, the blob storage was the first, then all the managed data tiers. And as I mentioned with Azure Site Recovery, you saw how I configured a disaster recovery schema for my VM.
Yep, and by the way, one of the use cases for Azure Site Recovery is not necessarily use our paired regions, but essentially use your local data center and use Azure as your paired region. Azure Site Recovery can also work with your local data center or local Azure stack, which we also discussed in many different sessions. But you can essentially use Azure Site Recovery between your own local region and Azure, one of the Azure regions as your parent region.
In case you plan your own disaster recovery schema, you're building an application or building a service, so keep in mind that within a region, you'll have availability zones and scale sets and availability sets and VMs, and then at the end of the day, you'll create another region, and you'll just use our traffic manager between as a global entity to redirect traffic to one of the regions. You can have it as active standby, and then your recovery plan, as long as data is replicated, then your recovery plan could be just to launch the VMs, the backed VMs, or have them running in an active fashion.
Of course, for active, you need some kind of data replication strategy, and you definitely for data replication need to take into account the latency between the regions and region pair. Once again, they cannot be too close. No one canceled yet speed of light. It's still in effect. So you might want to take that into account when planning for your data replication strategy. In many cases, customers are able to shard the data in such a way that maybe one of the regions is primary for some, one of the regions is primary for others. Depends on your service size. hopefully your service is big enough and you are getting into those issues, or will get into those issues one day. But there is definitely, when your service is big enough, you are definitely able to use paired regions beyond simple standby active passive scenario. So I think we went and discussed majority of the relevant scenarios, majority of the relevant features we already had and we just released. There's definitely much more in the portal, and you are welcome to take a look. One thing we didn't have time to mention is our multi-cloud strategy, essentially having clouds which are not connected to Azure cloud, at least directly, in specific regions like China, like Germany and others, where we allow our customers to comply with local jurisdiction and have local data which is not leaving the country under any circumstances.
Yeah. And going back to your sleeping patterns, I'm sorry, last night party was too much for me. As I understand Azure, the goal here, I see just the 4 nines. So how do I get to the 5.9?
And I think this is about the application design. Azure on average can give you high nines, but it's also important to keep your application using the right features, using the right scenarios that Azure provides and design for failure.
All right. So as you've seen, we started from the physical regions, availability zones, went up the stack with full domains and planned maintenance, and also surfaced capabilities to you to use for better availability. So either activity logs or the scheduled events, and use those, and hopefully you'll get better sleeping patterns than us.
Yeah, thank you.
Thank you very much.
We are using, by the way, all those to implement our scenarios, our internal features in Azure. So nothing here is untried. We are not offering any functionality here that is not used by Azure itself to implement its own high availability. And yeah, we are getting to sleep better lately, yeah. Please fill evaluation forms. We have another couple of minutes for Q&A. I think we don't have much time for frontal Q&A. Feel free to come to the stage and ask us questions. Thanks a lot for attending. Thank you for the time. It's Friday. Acknowledge that. Thank you. Thank you.